Now, the next topic is conducting polymers. Now, if we see the conventional polymers, all conventional polymers, they are electrical and thermal insulators, or the conventional polymers are insulators. Why they are insulators is because they are not having free electrons. So polymer backbone is not having availability of free electrons. So because of non-availability of free electrons, the conventional polymers, they are conductors. Conventional polymers means all the polymers which are natural or we have synthesized. So they are all the conventional they are referred as conventional polymers, and all the conventional polymers, they are insulators. Why they are insulators? Because of non-availability of free electrons on the polymer backbone. But a conventional polymer can be converted into a conducting polymer, and the conductivity of the conducting polymer is of the range of 1.5 into 10 to the power 7 per ohms per meter. So this is the highest conductivity which a conducting polymer can develop. Now, conducting polymers are basically of three types, and the first is intrinsically conducting polymer. Intrinsically means because of their internal structure, particular conventional polymer can be converted into a conducting polymer. So intrinsically, the meaning of intrinsically is कि पॉलीमर का अपना स्ट्रक्चर ही ऐसा है जिसकी वजह से वो इजीली एक कंडक्टिंग पॉलीमर में कन्वर्ट हो सकता है. नाउ intrinsically conducting polymer is of two types. The first is pi conjugated system conducting polymer. Now, in this pi conjugated system conducting polymer, the polymer can be made conducting because polymer is having pi electrons. So because polymer is having pi electrons, so it is going to have pi orbitals. Now, these pi orbitals, they undergo overlapping, and when these pi orbitals, they undergo overlapping, we get a valence band, which is a lower band, and on above that we get a conduction band. So because of the formation of these two bands, valence band is completely filled or half filled, and conduction filled is half filled or it is empty. So if we provide energy, the electrons can move from valence to conduction band, and as the electrons, they start moving, we say that the particular substance will start conducting electricity, or here polymer will start conducting. So this is pi conjugated system conducting polymer. Why? How it is becoming conductor? Because such polymers, they have got pi or pi electrons. If they are having pi electrons, they will have pi orbitals, and these pi orbitals, they overlap over the entire chain of the polymer, forming valence band and conduction band, and because of the formation of these two bands, they will start conducting. The second type of intrinsically conducting polymer is doped conducting polymer. In case of to explain doped conducting polymer, we say that intrinsically conducting polymers, they have low ionization energy and they have high electron affinity. Because of these two properties, it can easily undergo oxidation or reduction. So when it can easily undergo oxidation and reduction, that means when it is undergoing oxidation, a positive charge is created on the polymer backbone, and when it is undergoing reduction, a negative charge is created on a polymer backbone, and because of the creation of positive or negative charge, the polymer starts conducting. Now, doped conducting polymer is of two types. The first is p-doping. P2king means we have a polymer and this is treated with the Lewis acid. So this is a general structure of polymer. We are treating it with Lewis acid. When it is treated with Lewis acid, it undergoes oxidation. And when it undergoes oxidation, the polymer backbones develops a positive charge. And because of the formation of this charge, and when this charge comes on the polymer backbone, the polymer starts conducting. It takes place in the presence of p dopants, and they are iodine, bromine, or PF6. Second is N-doping. In case of N-doping, the polymer is treated with a Lewis base. And when it is treated with the Lewis base, it can undergo reduction. And when it is undergoing reduction, the polymer backbone develops a negative charge. Negative charge, again, when the polymer develops a negative charge, it will again start conducting. Now, it takes place in the presence of N-dopants, and they can be lithium, sodium, calcium, or FeCl3. So these are the two types of intrinsically conducting polymer. Why we are saying intrinsically? Because in structure ऐसा है so that they can be easily converted into conducting polymer. The first is pi conjugated system conducting polymer, where we have pi electrons. The polymer is having pi electrons, and because it is having pi electrons, so it will have pi orbitals. Now these pi orbital overlap over the entire polymer chain, forming valence band and the conduction band. And as these bands are formed, and if we provide energy, the electrons from valence band can move to the conduction band, and thus the polymer starts conducting. The second is doped conducting polymer. Intrinsically conducting polymers are of low ionization energy and high electron affinity. Because of these two properties, they can easily undergo oxidation and reduction. So when it is oxidized, a positive charge is developed on the polymer backbone, and when it undergoes reduction, a negative charge is developed. Now this process of developing of positive and a negative charge by oxidation and reduction is known as doping. Doping is of two types, P and N. P when the polymer is treated with Lewis acid, and N when the polymer is treated with Lewis base. In P doping, a positive charge is created, and N doping, a negative charge is created. So this is intrinsically conducting polymer. The second type of conducting polymer is extrinsically conducting polymer. In case of an extrinsically conducting polymer, we are going to add a substance from outside to the conventional polymer, and the conventional polymer is converted into a conducting polymer. Now, this is also of two types, and first is conductive element filled conducting polymer. Now, here we take a conventional polymer and to this conventional polymer we fill it with a conductive element. कोई भी एलिमेंट जो इलेक्ट्रिसिटी या जो कंडक्ट कर सके उसको इसके अंदर फिलअप कर देते हैं. फॉर एग्जाम्पल कार्बन ब्लैक, metallic oxide, or metallic fibers. So when they are going to enter into this, the conventional polymer holds them as a solid entity, and because these conductive elements are filled up in these polymers, then it starts conducting electricity. Now the polymer which is obtained by this method is having a very good physical and chemical property, and it is highly durable. Now under this we have a value which is known as percolation threshold. नाउ पर्कोलेशन थ्रेशोल्ड, अब ऐसा नहीं है कि हमने कंडक्टिव एलिमेंट इसमें भर दिया तो वो हमेशा कंडक्ट करने लगेगा. कंडक्टिव एलिमेंट की एक मिनिमम क्वांटिटी है. अगर उससे कम कंडक्टिव एलिमेंट हम कन्वेंशनल पॉलीमर में फिलअप करेंगे देन इट इज नॉट कन्वर्टेड इनटू अ कंडक्टिंग पॉलीमर. सो पर्कोलेशन थ्रेशोल्ड इज द मिनिमम amount of conductive element which should be filled in this conventional पॉलीमर. सो इसकी भी एक कंडक्टिव एलिमेंट की एक मिनिमम अमाउंट है जिसको हमें फिल करना पड़ेगा कन्वेंशनल पॉलीमर में, और तभी कन्वेंशनल पॉलीमर कन्वर्ट हो पाएगा इनटू अ कंडक्टिंग पॉलीमर. द सेकेंड टाइप ऑफ एक्सट्रेंसिकली कंडक्टिंग पॉलीमर इज ब्लेंडेड पॉलीमर. ब्लेंडेड कंडक्टिंग पॉलीमर, इसमें क्या करते हैं, एक कन्वेंशनल पॉलीमर लेते हैं और उसको मिक्स करते हैं विद अ कंडक्टिंग पॉलीमर. कंडक्टिंग पॉलीमर जिस भी तरह हमने बनाया हो, तो कन्वेंशनल पॉलीमर इज मिक्स्ड अप विद दिस कंडक्टिंग पॉलीमर. अब ये जो मिक्सिंग है ये फिजिकल भी हो सकती है एंड केमिकल भी होती है. So either conventional polymer is mixed up with the conducting polymer either by physical means or by chemical means. But the properties and we get a blended polymer. The properties of blended polymer are very good. They have got good physical, chemical, electrical and mechanical properties. These blended polymers. So this is how blended polymers are formed. So these are two extrinsically conducting polymer, conductive element filled conducting polymer and blended polymer. Now the third type of polymer, conducting polymer, is coordination conducting polymer. In case of coordination conducting polymer, a charge transfer complex एक चार्ज ट्रांसफर कॉम्प्लेक्स फॉर्म करते हैं बाय विच इज फॉर्म्ड बाय मेटल एंड अ लिगेंड, एंड दिस चार्ज ट्रांसफर कॉम्प्लेक्स कंटेन्स द पॉलीमर, कन्वेंशनल पॉलीमर. अब क्योंकि कन्वेंशनल पॉलीमर में एक चार्ज ट्रांसफर कॉम्प्लेक्स भी है तो ये चार्ज ट्रांसफर कॉम्प्लेक्स अपना चार्ज इस पॉलीमर को ट्रांसफर कर देगा, और जब चार्ज ट्रांसफर कॉम्प्लेक्स कन्वेंशनल पॉलीमर को अपना चार्ज ट्रांसफर करेगा देन दिस विल गेट charged, and once the conventional polymer gets charged it will start conducting electricity. So we have three types of conducting polymers: intrinsically conducting, extrinsically conducting and coordination conducting polymer. Intrinsically conducting दो तरह का है, pi conjugated system conducting polymer and doped conducting polymer. Then extrinsically conducting polymers भी हमारे दो तरह के हैं, conductive element filled conducting polymer and blended conducting polymer. Then coordination conducting polymer is जहाँ पे conventional polymer के साथ एक charge transfer complex है और ये charge transfer complex अपना charge जो है conventional polymer को transfer करेगा and the conventional polymer will start conducting. Now then we have applications. Applications of conducting polymers. Now in their applications it can be used in rechargeable batteries, or it is also used in button batteries, जो small batteries होती है, button batteries. Then it is used in optical devices. It is used in telecommunications. It is used in telecommunications. It is used in wirings of aircrafts. It is used in solar cells. It is used in photovoltaic cells. Then conducting polymers are used in molecular wires and switches. And last, they are used in biosensors and chemical sensors. So these are some of the applications of conducting polymer, and conducting polymer is an important topic. So if I summarize, then conventional polymers, they are insulators, but conventional polymers, they can be converted into a conducting polymer जिसकी conductivity इस range में होगी. Then conducting polymers are of three types: intrinsically conducting, which is of two types, pi conjugated system, and doped conducting polymer. The second is extrinsically conducting polymer, which is again of two types: conductive element filled conducting polymer and blanded polymer. Then coordination polymer, coordination conducting polymer, and then we have got applications. It is used in rechargeable batteries, in button batteries, optical devices, telecommunication, in wirings of aircraft. It is used in solar cell, photovoltaic cell, molecular wires and switches, biosensors and chemical sensors.